Hi, this what you see is a really big battery, quite old and from Exide Sonic. It's a C20 150 ampere hour tubular inverter battery. These four are the wires coming out from the battery case, which then are connected to my 1500 watts pure sine wave inverter for turning on my lab lights and power tools. Although I still don't have a charger for this battery, so I decided to make one with this computer UPS transformer. This side is 220 and this is 12. Even though the 220 volts side has many wires, we have to choose any two, keeping this black wire common for all the three cases. Here the meter is being pointed at AC voltage measurement mode and the pinouts are connected to the output of the transformer. So guys, output voltage result for yellow and black pair is 16 volts, as you can see. Choosing the other wire, green, output voltage for green and black pair is 13.77 volts, very close to our requirement. Let's try blue. Output voltage for blue and black pair is the maximum 19 volts and the transformer core is vibrating. Let's measure the AC output current at an output of 13.77 volts using this bulb. So turning on the switch, the output current is as high as 7.5 amperes. Oh. Now for charging the battery, we need to convert the AC output from the transformer to DC using this bridge rectifier. Don't forget to add a capacitor at the output as well. AC. The meter has been pointed to DC voltage measurement mode and the output is taken from the capacitor with rectifier and transformer connected before them. Let's turn on the switch. As you can see that the output voltage is as high as almost 18 volts, which is too high for any 12 volts battery. Batteries are going to die. And initially you saw that for AC voltage measurement, the output was only 13.77 volts. Why is that? That is because the AC voltage always keeps on changing from 0 to peak and then again from peak to 0. Therefore, the meter measures the AC voltage in RMS form, which is root mean square. But in case of DC measurement, especially when the power supply is connected to a capacitor or a battery, the meter has no choice but to measure the voltage at which the capacitor or battery is charged at, which is always the peak value, and peak value is always higher than the RMS value. So for that reason, I had to test so many different types of UPS transformers. And finally, the best results were seen for this transformer. It's a high current center tap transformer. Here I'm using the black and yellow tappings for the input. Now let's connect it to a 220 volts power source for testing it. Here as you can see that the output voltage is exactly as we need, between 14 to 14.4 volts. Let's do some current measurement using my 12 volts 100 watts car headlamp bulb. Okay, so turning on the switch, it's producing around 10 amperes. So at present the output is close to 120 watts. So guys, that's my inverter battery, and you see these two thin wires, red and black. These are coming from this electric exercise bicycle. And the battery voltage, as can be seen, is 12.45 volts DC. So guys, here I've connected the power supply to the input, and the output from the capacitor has been connected through this wire and clips to the terminals of the battery. And here it is feeding the battery with 4 amps. And if we go for the change in battery voltage, it's 12.79 right now. Let's check the diode temperature. Yeah, it's quite hot. This is a 12 volts 21 amperes battery pack, and if we see the overall voltage, it is only 12.15. So let's connect my battery charger cables, red and black, to this battery pack. You can see that the voltage has started increasing, indicating that the batteries have started charging. Now because this battery pack is only 21 amps, but the battery that I showed you before was 150 amps, so obviously this is going to charge much faster than that one. So as you can see that the battery is charging, and our circuit or this battery charger is working really good. So with that, I'm finishing off the video. See you in the next one. Bye bye. Hit like and don't forget to share and subscribe. this is a transformer. Now guys, there are 4 wires coming out of the transformer, 2 for primary and 2 for secondary, but all the 4 wires look alike. So guys, here I'm doing the resistance check, and as you can see that this side is showing only 0.8 ohms, so it is the low voltage secondary side. And for the other side, as you can see that it is showing 7.7 ohms. So this side becomes the high voltage side. Now I am connecting it to 220 volts AC supply. And to the output low voltage side, I am connecting a multimeter to measure its output voltage. Connecting it to the socket and turning the mains supply on. Keep watching the multimeter. You can see that the output voltage is around 27 volts. This what you see is a 24 volts 250 watts bulb, which I'm going to test with this transformer. And I'm also going to measure the output current with the help of this clamp meter. Okay, you can see it can measure up to 600 amps AC or DC. Now it's time to connect the bulb carefully, not to create any short circuit because the current output of this transformer is very high. Oh, actually I have to change it from DC to AC mode. You see it is flashing DC, changing it to AC. Yeah, AC, true RMS. Turning it on. Yeah, 11.83 amperes. Close up now. You see, almost 12 amperes. And guys, this milling machine and drill press provides me with a lot of precision in working and making of projects. And as you can see that the transformer now has been perfectly placed on the wooden board and looks really nice and well stabled. 2 nuts and bolts are enough to keep the transformer steady and in one place. The little space left below the transformer is going to be useful now. Now guys, this is a 35 amperes AC to DC converter or bridge rectifier, KBPC 3510. And guys, one more thing, don't forget to subscribe my channel and hit that bell icon if you like this video. You can also hit like. This terminal that you see here, it is showing AC, and this one that you see here, it is showing positive. So if this one is AC, then it's diagonal opposite, which is this one. This is going to be AC as well. And when this one is positive, then it's diagonal opposite, which is this one. This one is going to be negative. Now guys, I'm going to use this DC capacitor 31,000 microfarad and 50 volts DC to improve the output DC line from this transformer. So guys, here as you can see that I'm using an aluminum strip for holding the capacitor in place, and it is working pretty good and it also looks good. Now I'm going to use 2 wires to connect the capacitor to the rectifier, keeping in mind positive to positive and negative to negative. Also, it is not necessary that the wires are thick or thin because this capacitor is only for purifying the DC line. So I'm using thin wires here. And one more thing guys, the capacitor that I have used here is 31,000 microfarad and 50 volts DC. And I'm going to use this 4 mm high current cable to connect to this rectifier, which is going to be our final output. Now guys, I'm planning on converting it into an adjustable power supply. So for that I'm going to use this fan regulator. It's barely visible, 450 watts, and this transformer is 250 watts, so this should work with this. Okay. Well, I'm using here a double-sided tape to stick it to this wooden board. Yeah, this place seems great. Yeah, stuck pretty good. So guys, everything is complete now. All I have to do is connect this 220 volts plug to the transformer and fan regulator. As you can see guys, that the supply has been connected. So let's turn it on and hope that nothing bad happens. Okay. Yeah. Seems like everything is fine. Now guys, the capacitor might be charged. Well guys, I'm not 100% sure about why and how this capacitor is gaining charge. Maybe because of the ripples that it is connecting from the AC line. So anyways, let's turn it on. You can see it is showing 24 volts and I can increase it with this knob. From 24, let's see how much we can go. 36. 38. So this power supply is going to work from 24 to 40 volts almost. Pretty good DC voltage that I'm getting here. So guys, it's time to do final tests on it with some incandescent bulbs and with some DC motors. Okay, so turning it on. Okay, let's turn off the lights. Yeah, the lights have been turned off. The bulb is glowing pretty good. Now let's see how bright I can get, although this might get fused and I don't want that. You see it is glowing pretty bright. I should not take it too bright because it might burn out. Let's turn it off. Well guys, now comes the time that you have all been waiting for, the DC motor testing. Now guys, this one is one of my favorite motors that I used in my electric bike project. Yeah. Let's increase. That is the full RPM at the maximum input. And the current drawn is only 0.12 amps, which are the losses. Let's try to stop it and you will see some ampere increase over here. You see the amperes are increasing. Once again, see how much maximum I can do. Yeah. So 3.5 amps was the max that could be done. Well guys, now comes the 24 volts e-bike motor. It consumes a current of up to 26 amps. It has 500 watts. Now this is going to be pretty big for this power supply, but let's see how good it performs. Okay. You see the running current for this motor is a lot higher. Running at a pretty high speed and consumes a no load current of 1.5 amperes. The losses for this motor are pretty good because of the higher number of brushes and bigger power rating. Well guys, you see that the amperes drawn are like 1.5 amps. Okay, so yeah, not that high, but when I'm going to increase the RPM, suddenly there is going to be a peak. Like not a very high peak, but the amps are going to increase. Okay. You see the peak was as high as 5 amperes or 5.5 amperes. Well, this motor should run very slow because like it works at 220 volts. You see, it has started running.
and the circulating amps are very less. Anyways, that's the full speed, and the intaking current is only 0.13. Let's increase them. Yeah, you see, when I stop it completely, then the maximum current under short circuit condition flowing through this motor is only 1.5 amperes. That is very less. You see, 1.5 amperes, that's it. Actually, higher current will flow through this motor, but for that I will have to supply higher voltage, like 180 to 220. I've turned off the supply, but it is still running because of the charge left in the capacitor. You see, I've stopped it, but still it is running. Well guys, let's skip the motors in between and arrive to this high current starter motor. It is going to draw maximum current, and this is going to be a pretty good test. Although this is a 12 volts motor which can actually damage this power supply, but still I'm going to test it. I'm pretty interested in seeing the results. Let's hope that it does not burns out, because I don't have another transformer like that. Yeah, first I have to turn on the supply. Yeah, and of course I also have to take care of the fan regulator. Okay, high current spark is going to be there. Get ready guys. Whoa, shit. Oops. This is going to be bad. Okay, so let's try it this way. I don't want to destroy the sheet. Okay. Whoa. You saw the current, it was somewhere around 25 amperes. Peak of 27 amps. Wow, spark is very high and the motor might just burn out. I should not like stretch this experiment more. Let's turn this off. One thing is clear, that the supply is working very good, and the current output is even more than I expected. After adding the capacitor and the rectifier, both the voltage and the current rating has improved like flawlessly. So anyways guys, if you liked this video, just hit that subscribe button so that you can watch my upcoming videos. See you in the next one. Bye.